All right, good morning. We're going to talk about nonlinear equations today. This is section 8.4. I'm sorry for skipping around a little bit. Pretty much nonlinear equations looks a lot like linear equations, except most of the time you are going to have to use substitution. Occasionally you get to use elimination, but for the most part, we have to use substitution to make anything work. All right. So it's hard to, line up. You don't always get to line up everything in terms of like you have matching stuff. When you do, that's great, but you don't always get to do that. Okay. So I'll stop talking about random stuff like this and let's get into working the problems. Okay. We'll see what we have. Okay. So they often suggest you graph things in order to make sure you're getting the right number of solutions. It's kind of a tough thing to deal with. Just getting like, what are we doing? Okay, so this is y equals x squared minus 6. We know how to do that. That's going to be x squared. So we have regular x squared, and then we have a vertical shift of 6 down. Okay, so let's see here. If I put in x equals 1, then 1 squared is 1. 1 minus 6 would be 5. Okay, 1 minus 6 would be a negative 5. So x equals 1. Okay, we move up by 1. There's our answer for that. And now we're going to take x minus y is equal to 6. Okay, so if we take where's that? There it is. X minus y is equal to 6. So if y were equal to 0, okay, x would be 6. Okay. And if x were equal to 0, then negative y would be 6, or y would be negative 6. Okay. So let's go ahead and plot those points. We've got, let's see here. If x were 0, y is negative 6. So x were 0, y is negative 6. And we have that one. So let's go ahead and place our point and place our point. Okay, and we'll say that's good. Now, if you wanted to zoom in on this a little bit, I don't know if you can, but you can see that there is a little arc here with the parabola, and so the line should intersect it in 2 places. Okay, so that's what we have for that. So we'll check our answer. All right, now use the system, or solve the system by using substitution. I don't really have, I'll never write the instructions like solve by substitution or solve by elimination. Like that's on you. You choose the best method you think is going to work. Most of the time it is going to be substitution now. So what do we have for a problem? We have x squared minus 6 equals y. So we have y equals x squared minus 6. We have x minus y, right? X minus y is equal to 6. All right. So let's see here. Why don't we do something like this, and we'll say x is equal to 6 plus y, or y plus 6. Right? No, I don't want to do that. I want to say y equals. I want to substitute out for that. I want to say that this is equal to 6 equals x minus y, add y to both sides, and then we'll subtract 6 to both sides. We'll say y is equal to x minus 6. Okay, that way when we have our equation 2, we have equation 1. So I'm going to put what I have for equation 2, and I'm going to insert it into equation 1. So we have x minus 6 rather, is equal to x squared minus 6. let's go ahead and add to both sides. So we're going to have plus 6 plus 6. We're going to subtract an x, subtract an x. So we have 0 is equal to x squared. These cancel, minus x. So x squared minus x equals 0. We have x, and x minus 1 equals 0. So we have x equals 0, x minus 1 equals 0. So x is equal to 1, x is equal to 0. Okay, now take either of these equations, okay, any of these equations that you would like. I would like to go with x minus y is, or y minus, no, x minus y equals 6. All right, so again, we'll say x minus 6 equals y. So when x equals 0, okay, we have 0 minus 6 equals y, so at y equals negative 6. And when x equals 1, no, I want this. When x equals 1, okay, we're going to have, we have here 1 minus 6 equals y, so 1 minus 6, that's negative 5 equals y, so we'll have y equals negative 5. So our 2 points, 0, negative 6, 1, negative 5. Okay, that's going to be our solution. So solution set is, we need, parentheses, we need fine. We need 1 and 2 of these. I wonder if it'll do this for me now. No. Oh, that's empty set. Sorry, we want this, and then this guy, and that's on this guy. Okay, I didn't want the empty set. Okay, so we have 0, negative 6, and 1, negative 5. Okay, and that's our solution set. Let's go ahead and check. Right, and then we're set to go on to the next one. I'm going to skip a couple, do it that way. Okay, so what do we have here? We have y is equal to negative 2x cubed. Plot 5 points on the graph. 2 negative, 2 positive. All right. So we have here, okay. Right when x equals 0, y is equal to 0. When x equals 1, okay, when x equals 1, we have negative 2 times 1. Okay. When x equals negative 1 cubed is negative 1. Negative 2 times negative 1 is a positive 2. Okay. And well, I don't think this is going to make it matter, but let's go down here. So we have y equals negative 2x cubed. Okay, we have y is equal to negative 2. If I plug in 2 cubed here, that's going to be negative 2 times 8, which is negative 16, which is bigger than I want. Tell you what, let's try a different answer, different question, not a different question, but different point. How about we say when y is equal to negative 2x cubed, why don't we take something like 3/2 cubed times negative 2? So this is going to be 27/8 times negative 2. So that'll be negative 27/4. Let's see where that is. Point. I want 0. No, I want 2. I didn't take 2 because I didn't press 2. We'll take this as negative 27 fourths. Yeah, that's okay. Plot point. And we'll take positive, or negative 2 rather. And because of that negative in there, we're going to have 27 fourths. Plot point. Okay. Oh, look at that. Okay. Now we'll go ahead and plug this in. Yeah. Oh, congratulations. Did it. Why did you not like this? It's 2/8 is a quarter. Yeah, it is. Okay, well, it wouldn't let me write in 2 because that's too much. Oh no. Oh, I know what I did wrong. I put in 3/2, negative 27 fourths. It's negative, come on. Plot that point, and 3/2, negative 3/2 rather. Negative, and we'll type in positive 27 fourths. What did I just plot? All right, let's see what we have. Okay, there we go. That looks a little bit better. Boom. Okay, and we'll say recheck. All right, it's happier. All right, and then graph negative 2x. So instead of going up this way, right, it's going to go there. So negative 1 is going to be negative 1 times negative 2, which is going to be 2. And if I plug in 1 here, okay, we have, actually plug in 0, couldn't I? Let's plug in 0. Okay, so it's really easy to see that we have 1, 2, 3 points of equality, 3 points of intersection. So we have negative 2x cubed is equal to y, and we have y is equal to, up here, negative 2x. All right, so we're just going to substitute these. Okay, so we're going to say we have negative 2x is equal to negative 2x cubed. Let's knock that out. So we have x equals negative, no, that's not negative, plus x cubed. So we're going to have 0 is equal to x cubed minus x, or x cubed minus x is going to be 0. Let's go ahead and factor out an x. We're going to have an x minus 1, x plus 1 is equal to 0. So x equals 0, x equals 1, x equals negative 1. Okay, and if I go back to my value here, we've got negative 2x is equal to y. That's from this equation. And all we have to do is plug things in. So when x equals 0, we have negative 2 times 0 is equal to y. So we have 0 is equal to y. Okay. When x equals 1, okay, we've got negative 2 times 1 is equal to y. So we have negative 2 equals y. And we have x equals negative 1. We have negative 2 times negative 1 is equal to y. We have positive 2 equals y. Okay, so the 3 points for x's, right? We have 0, we have negative 2, and we have 2. Okay. Oh, no, we don't. Let me go back. I put in the y's. X equals negative 1. positive 1. So when x was 0, y was also 0. When x was negative 1, y was 2. And when x was equal to 1, y was negative 2. Those are our 3 points. Okay, the solution set is, we'll put in a one of those, and we're going to need 3 points. So 1, 2, 3. All right. So we have 0, 0, 1, negative 2, negative 1, positive 2. Answer. Oh. Oops, not that. All right. Okay. Just commas. That's it. The only thing that was mattering. Okay. So this one solved by the addition method, elimination method. And the reason why this is going to work is you see these two 4xy's here. So the thing you don't want to do, all right, let's go ahead and take a look at what this is. This is 4xy plus 9y squared equals 60. 4xy plus y squared equals 28. Okay. So even though we could eliminate the y squareds, the problem is that I'm going to have a 4xy at the end of this, and we're still going to have 2 variables, but I've used up one of my equations. So we've got 2 variables with 1 equation, and that's going to be a little rough to get through. All right. So if I eliminate the 4xy's, okay, then multiply this by a negative 1. So we've got 4xy plus 9y squared equals 60. And then here we have negative 4xy minus 9 squared. No, just y squared. Minus y squared is equal to negative 28. Notice that both x and y go away, and I'm just left with a y squared term, which we can solve for. That's going to be y squared, 8y squared equals, and what are we going to have here? We have 5, 10, then we have a 10 minus 8 is 2, and 5 minus 2 would be 3. Okay, so we'll have y squared is equal to 4. 32 divided by 8 is 4. Y squared, y would be plus or minus 2. Okay. So either equation after this is going to be fine. Okay. When y equals 2. Okay. We have 4x times 2 plus 4, because y squared is 4, is equal to 28. Okay. So we have 8x plus 4 equals 28. Okay, subtract 4, we have 24 is equal to 8x, and then x would be 3. When y equals negative 2, we have 4x times negative 2. Y squared is still 4 equals 28. So we have negative 8x, okay, plus 4 equals 28. So negative 8x equals 24, and x would be negative 3. Or y rather. No, we're on the right one. So our 2 points are going to be 3 and 2. And we have negative 3 and negative 2. Right? This would be a hard thing to graph because of the mixed term, the xy. It's going to be difficult. It's not impossible, but it is going to be a little rough to graph this thing. So we're not going to worry about that because it's nice to know, but at the same time, like, There's not a lot we could do with this. And then we're going to go to our back to our problem and type this in. So 3, 2, and negative 3, negative 2. Okay, we have a solution set. We have one. Oops, wrong one. No. There we go. And comma, and that. And we have 3, 3, 2, and negative 3, negative 2. Wait, I think I got the x's wrong, didn't I? Didn't I get them mixed up? No, I didn't. We're good. Okay. We're set. Okay. So, but again, usually you're going to want to use substitution, but occasionally we can use elimination. Case in point, can we use substitution here? Probably not. Or no, can we use elimination? Probably not. Substitution is going to be the way to go. All right, let's have a look. We have y is equal to 1 over x, and y is equal to the square root of x. If I wanted to graph it, because I know they don't give me a chance, there's y equals 1 over x. Here is y equals square root of x. Okay. So when I only get one solution, I'm not going to be that surprised. All right. So let's see here. So we have y equals this, y equals that. So we could just set them equal to each other, right? We could just say the square root of x equals 1 over x. Let's go ahead and put all the x's on one side. Okay, so we have x root x is equal to 1. And I'm just going to rewrite this a little bit. This is x to the 3 halves, right? This is 2 halves times 1 half. So add the exponents, equals 1. And now what we're going to do is we're going to square both sides. So x to the 3 halves squared is equal to 1 squared. And we end up with x cubed equals 1. Okay. And then we're going to have x equals 1, taking the cube root of both sides. All right. Plug in x equals 1 into either of these two equations. Okay, I think you could see by inspection y would also be 1, right? Because 1 over 1 or the square root of 1. And there we go. Okay. And the reason why we don't worry about the negative side is because the square root doesn't exist on the negative side. Like, yes, they are imaginary numbers there, but notice the coordinate system that we're using on. We're using on an x, well, we're using on an xy axis, okay, not in a real and imaginary axis. So while yes, there could be imaginary numbers here, okay, there will not be, there won't be anything over here. We could also, from here, okay, technically we could use Demoff's theorem to get the two imaginary values for x. Okay, well, we're not going to worry about that. Okay. Check answer and move on with our lives. Okay. Find the dimensions of a rectangle whose perimeter is 42 and area who is 90. Okay, so I'm going to pause this for a moment. All right, so there we go. So let's draw a picture, right? What's a rectangle? And my parameters would be like y will be the top and bottom side. No, side to side, left and right side. Because that's my y up and down. X will be top, bottom. All right, so my perimeter here is 2 x's, 1, 2, plus 2 y's is equal to, what did they say the perimeter was? The perimeter is 42. I'm going to immediately divide everybody by 2 to get x plus y is equal to 21. And then the area is x times y is equal to, what did they say? X times y is 90. Look here. We have two equations, two unknowns, we're set. All right. Now it is up to you to decide how to solve this for the rest of the way. We have x plus y equals 21, x times y is equal to 90. What I recommend is using a substitution. Okay, so from equation 1, we're going to say that y is equal to 21 minus x. All right. What we're doing is subtracting x from both sides. And then we're going to take what we have from equation 1 into equation 2. So we have x, right, times what's y? Y is 21 minus x is equal to 90. So we have 21x minus x squared equals 90. So we're going to subtract 90 from both sides. So we're going to say negative x squared plus 21x minus 90 equals 0. Now I'm going to multiply by -1 because I work better with this being a positive 1 as a coefficient. So we have x squared minus 21x plus 90. And now we have to figure out how to turn 21 right into something with 90s in it. So what could 90 possibly be to get to, is it 90? It's 90. Okay. What could 90 possibly, could we break this up into in order to get 21? Okay. So let's see here. All right. So that's 3 and 30. 4 and 95 by 5. This is 3 times 2 times 5. So this could be 6 and 15s. Hey, wait a minute, 6 and 15 add up to 21. I like that. All right, so we have x minus 6, x minus 15. I multiply these together, I get positive. -15, -6 is -21. All right, so we have x is equal to 6, x is equal to 15. Okay, and then pick either of your, pick any of your equations that you have for this. We're going to say x plus y equals 21, right? And so the equation we have. Yeah. So when x equals 6, we have 6 plus y equals 21. So y is equal to 15. And when x equals 15, we have 15 plus y is equal to 21, or y is equal to 6. Okay, so we have a 6 by 15 painting here, or picture, or park, whatever the heck they're, rectangle. Okay, and we'll be able to go with that. So this is going to be 6 and 15. Okay, or 15 by 6, both will be correct. Okay, at least I hope they will be. All right. Let's do this one. Okay. I like this one. So this is a good one to deal with. We have an initial concentration that we don't know. So somebody probably injected a drug into themselves, and we don't have no idea what that is. But after 3 hours, the drug concentration is 0.68 micrograms per deciliter. And after 4 hours, the concentration is 0.625. So maybe they could get something of at least the amount that was started. Okay. So we have two problems here. We have two equations. So we have AT equals A sub 0 e to the negative KT. Okay. So we have A of t is equal to A sub 0 e to the negative KT. And we have a Well, when t was equal to 3 hours, a sub 0 is equal to 0.68. When t was equal to 4 hours, we had a sub 0 is equal to 0.625, right? So notice we have, right, we have two equations. We have a sub 0, we have k, we have to solve for. Okay, so let's set this up a little bit. We've got a sub 0 e to the negative 3k, because t is going to be 3, and that is equal to, at, right? It wasn't 0, it was at. Is equal to 0.68. Okay, and we have a sub 0 e to the negative 4k is equal to 0.625. We could set these guys equal to each other. Okay, so how do I want to do? I want to say a sub 0 e. It doesn't matter which order you do it in. I'm just trying to make it look pretty. I keep trying, right? Okay. Nope. 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 So much for making it look pretty. Okay. Get rid of all you guys. All right. Oops. What am I doing? Okay. So we have these two pieces here, right? A sub 0 equals that, a sub 0 equals that. Okay. Why don't we go ahead and multiply both sides here by e to the 4k? Okay. E to the 4k. Really? E to the 4k times e to the negative 4k, that's going to be 0. Or it's going to be e to the 0, right? Because we add the exponents, that's e to the 0. That's 1. Okay. So what we're going to have here, right, is a sub 0, right, is equal to 0.625 e to the 4k. Okay, and I apologize for the fact that the pen has now decided to, take a little bit of lag here. Same thing happened over here. Okay, so we just multiply by e to the 3k, e to the 3k, in order to eliminate. Okay, now I've got a sub 0s on both sides. All right. So we are now set to be able to put these on each side. Okay, so we're going to say I don't want to do this. I want to say something like 0.625 e to the 4k is equal to 0.68 e to the 3k. Right? What we're going to do is I'm going to divide both sides by e to the 3k, so it's going to be e to the negative 3k, e to the negative 3k. Okay, and we're going to divide both sides by 0.625, 0.625. All right, e to the 3k times e to the 4k. The bases are the same, we add the exponent, so it's going to be e to the k is equal to, that's 1, and then we take 0.68 divided by 0.625, so this is 0.68 divided by, really, 0.68 divided by 0.625, and 1.088. Well, we got to solve for e to the k, and that's in an exponent position. How do we deal with that? You take the natural log of e to the k equals natural log of 1.088. So k, right, because it comes down in front, times the natural log of e, which we know is 0, or 1 rather. And that is equal to the natural log of 1.088. Okay. So that's my k. Now I got to solve for a sub 0. Okay. Pick any of the two equations you want here. Okay. Pick any of those two. How about we pick this one? Okay. So we have a0. We have, let's do it this way. We have e 0.68 e to the 3k is equal to a sub 0. So we have 0.68 e to the 3 times ln 1.088, and that is equal to a sub 0. And now all we're going to do is just run this through the calculator. Okay, we're set. So we have 0.68, okay, times second function, natural log, 3 times, and I'm just going to say answer because that's 3 times natural log, rather, 3 times the natural log of this answer. All right. And we come up with 0.87875, we'll go 876. Yeah, I didn't do it the way that the book structures it. I did. I just didn't show you what the steps were. They kind of hold your hand through all of this and just have you do it piece by piece. I skipped this part. So the first thing you're going to type in, right, is you're going to write down when it says substitute. Okay, we're going to have something like this equation here. That's what they want you to write down. All right. So it's not so bad, but but they are going to handle your way through it, which is fine. Okay, this is a tough problem. Okay, so it's a good problem though. Not saying I would put this one exactly on the test, but I think I have before. Okay, I think I have done this one before. It's a good final exam review question too. Okay, so that's our n equations with or 2 equations with 2 unknowns in nonlinear. So again, remember, when in doubt, try to substitute. It'll work out for you. Okay, so I'll leave it go there, and we'll come back into the next segment later. Okay, so go do homework. Good luck.